Good afternoon, everyone. Thank you very much for joining this presentation. My name is Hessam Azari Jafari, and I'm working as the Executive Director of the MIT Electron Conducting Hub. I'm also a research scientist in the Department of Civil and Environmental Engineering. All I wanted to say today, Anthony has already spoiled, so maybe not a good message here, but I would like to bring some numbers and values to share with you and to walk you through what we can achieve with EPDs nowadays and what are the common shortcomings or cautions that we should have in mind when we think about the EPDs and where LCA really needs to play an important role in the environmental impacts evaluation of the cement-based products, including UHPC, conventional, high-performance concrete, etc. This information is widely available on different ACI resources. There is a research paper that we published 2 years ago. There is a Concrete Research Council ACI Foundation funded projects on this topic that you can read a little bit about the details of that. And more recently, last year, we finished this tech note, and it was published in 2024 that you can read a little bit of more details about my presentation today and what the 130 committee members think about the use of EPDs and what we can do better in the future. But where did it start? It starts from several years ago, maybe around 10 years ago, when we thought about the lead credits, and this is where the industry stepped in and started generating EPDs. Actually, the cement and concrete industry is one of the most advanced ones in terms of the EPD generation, and the quality of the EPDs that are published by the industry is completely different from the others, construction materials as well, mostly because of the trials and errors and data quality that we currently have available for the cement and cement-based materials. So when you look at the LEED documentation, you will see that the main motivation is to report the environmental impacts using EPDs. You collect a certain number of EPDs and you're eligible for the credit, and if you can show that you are below the benchmark value, you can get additional points about the LEED certification system. But since then, there is a lot of difference, and there is much more momentum around EPDs that I wanted to share this screenshot from the Carbon Leadership Forum with you, that you can see there is a lot of different applications for EPDs, starting from using EPDs for regulatory purposes. You probably have heard about Buy Clean Acts in different states, incentive-based programs, public pilots and studies, agency programs for different DOTs, not only in the US, but also in Europe. It's very much prevalent, as well as the educations and government-funded tools. These decisions are all made for EPDs of concrete, asphalt, wood, glass, and steel. So what can you see in EPDs, and why should we be cautious when we are using EPDs? First of all, when you look at the EPD and its content, as you might have seen, we are only seeing the emissions associated with the first step of the life cycle, production. You can see the check mark in front of the construction product. This makes it ideal for vendor decisions. So when for example, an owner or a contractor wants to purchase their concrete or cement-based products, they would refer to the values in the EPDs. But when you go forward for whole structure LCA, we see that we need well beyond what is included in EPDs. So at the design stage, when we are evaluating different options for our bridge decks, for tunnels, pavements, engineering cementitious materials, we see that we definitely need beyond what is included in EPDs. But we have one step further, which is whole structure and whole life cycle LCA, where it's again at the design step, but we expect a different operational performance. For example, the energy consumptions during the use phase are different. Again, EPDs cannot answer this question in a comprehensive way because they only include the information about the production of these materials. So what do we do with EPD, and what other important and critical issues we should keep in mind. There are three important factors which I only focus on the functional equivalency here. There are many different documents. Again, I would encourage everyone to look at the documents that I shared on the first slide to be able to get more detailed information about all these three critical issues. But on the functional equivalence, when you look at an EPD, for example, this ready-mix concrete EPDs, the only performance metrics that should be reported is the compressive strength with an option to include a slump as well. But there are other important factors that will derive the mixed design, including constructability, durability, stiffness, density, etc. This would require us to think about one concrete mixed design that satisfies the performance, mechanical performance requirements, but requires a much different durability criteria in terms of freeze-thaw resistance, sulfate attack, corrosion of reinforcement, exposure to water, all these important elements that are well addressed in the ACI 318 codes. So when it comes to different applications, EPDs do not give us a full definition and answer to the comparative analysis. Comparing EPDs with same compressive strength, but for different applications, are not correct. The other important update that I wanted to share with you is about the key performance metrics, and I couldn't find a better example than the study by FHWA that was published around 4 years ago in the Pavement LCA conference, where there is a bridge deck here, as you can see, as a case study, and they comparatively analyzed two cases of conventional and UHPC concrete overlay, you can see on the bridge deck. And when you look at the EPDs, this is the environmental results that were calculated. So please bear in mind the y-axis. It's the production emission, and the unit here is kilogram CO2 per cubic meter of materials. And obviously, conventional concrete, we use less cement, we use more aggregates, a larger maximum aggregate size. UHPC per cubic meter has almost 4 times larger GHG emissions volume-wise. But there is a caveat here. EPDs do not include this important design information. This is where we need to compare the options based on designs. So in the conventional case, the thickness of the overlay is around 6.4 centimeters. UHPC thickness is around 3.8 centimeters. UHPC is much more durable against the environmental attacks and aggressive environments that you would expect in terms of freeze-thaw cycling, de-icing salts, etc. So over the 50-year analysis period for the study, the UHPC didn't need any reconstruction, as opposed to the conventional case where it needed to be replaced every 25 years. What is going to happen when we include the whole life cycle here? The result is completely different. The conventional concrete result is more than 6 times, larger than 6 times of the UHPC concrete mixture. Again, please pay attention to the y-axis. The y-axis for us is ton CO2 equivalent per bridge deck and for a specific period of time, which we specified as 50 years. So it's really important for us to consider the step of the decisions, whether we are at the design stage or procurement stage, when we want to use different tools available in the market. At the design stage, EPDs do not fully answer the questions, but for the vendor decision-making, where we have a full specifications associated with the design mixture, then we would have a better solution. Recommendations for comparing concrete even with identical or similar performance. We need to, again, emphasize on the specifications equivalent, and the mixture should be identified. But if we have even similar performances, we definitely need to consider benchmarks with different functional categories among the ACI communities and other concrete stakeholders. The functional categories that we will define will be like proxies that we will use to consider different performance criteria, including durability, mechanical, workability performance. Moving forward, the need for a PCR, a product category rule, which is the rules underlying and guardrails for developing EPDs for UHPC, and use LCA when you want to compare different compressive strengths of the concrete, where you can consider the impact of the properties of the materials, and durability is obviously an important factor to compare the systems against, as opposed to the volume of the materials only. With that, I would like to thank you for listening to this presentation, and very much excited to continue the discussion over the panel. Thank you, Kai.
Thank you so much.